I think we will be starting now the presentation of eDelivery. I guess that everyone is in the right room. So thank you for joining us to the primer on eDelivery. I guess that most of you do not really know what eDelivery is, since we are a very recent generic enabler of FIWARE. My goal is to just give you a bit of context. How come do we have eDelivery in the FIWARE Catalogue, and what you can do with eDelivery. My name is Joao, and I will be joined also by Brit and Joanna in the presentation. We will do it in 3 parts. The first part will be about introducing the Connecting Europe facility, followed by an introduction to eDelivery, and then we will have a demo. Okay? So the introduction to the Connecting Europe facility. We come from Brussels, the European Commission, and as you know, the Commission has different programs, and actually FIWARE benefits from one of the programs of the European Commission. So we come from the side of the e-government programs of DG Connect, and during the period of 2014 to 2020, the European Commission is investing about €1 billion in technologies that can promote the digital single market. And to do this, there are a number of generic enablers that are put in place in different domains of the EU, and one of them is eDelivery. So the context is actually this regulation that enables the Commission to invest €1 billion in these technologies until 2020. And we thought it made sense to have this partnership with FIWARE, given that FIWARE brings an audience of small and medium enterprises, of developers that can either benefit from the funding of CEF or can find others that are using these technologies to provide them services. The Connecting Europe facility is about this idea of the digital society. So eDelivery is not our single building block, as we call them, or generic enablers. We also work with eID, with e-signature, with e-translation, and electronic invoicing. As you can see here, this is all about the creation of the digital citizen of the future. So we believe that in a few years' time, most of you will be signing not with a pen, but with electronic signatures. You will be doing authentication using your eID, and for secure exchange of documents, you will be able to use eDelivery. And similar applies to businesses in Europe. And we are in contact, of course, with the member states and implementing these technologies in different sectors. We brought some brochures because the Connecting Europe facility offers grants. What does this mean is that if you are a small company or any enterprise interested to implement eDelivery, or if you are knowing a member state that would like to use eDelivery, you can receive funding. And we have some brochures explaining how you can apply to that funding. I think it will be too late for this year because tomorrow is the last day. But we still have the brochures. We have plenty of them. But next year there will be more funding rounds, and if you get to know what we offer, maybe you can benefit from it next year. So just to give you an idea that when we will talk about eDelivery today, we will talk from the technology perspective, but actually this is a technology that is used in many, many projects in Europe. In the healthcare domain, we have justice domain, social security domain, cybersecurity, business registers. So I really invite you to go to our website and see how this technology is being used in real life. I will now give the floor to Brit, and she will explain you what eDelivery is through a very simple example that you can all relate to.
Okay, so what is CEF eDelivery? Well, actually, basically CEF eDelivery is a solution that helps you to exchange electronic data and documents in an interoperable, secure, and reliable way. So it's actually a solution that helps you to set up a message exchange network. Two important aspects about Ceph eDelivery is that it is based on a distributed model using access points to exchange data in what we call a four-corner model, which I will explain a bit more in detail later on. And that it is payload agnostic, which means that it can be used to exchange any type of data or document. It doesn't matter if it's an invoice, a declaration, or anything else. And this makes eDelivery applicable in a variety of domains and sectors. As Joao already mentioned, e-health, in maritime domain, so in a lot of sectors and domains. So to explain a bit what eDelivery is and what the benefit of reuse is, I would like to use a specific use case for which we're currently implementing Ceph eDelivery. And I think most of you probably already bought online a product from a vendor in another country. But I hope that not too many of you had some problems in that process. Because sometimes, for example, looking here at the example, this guy or girl, she ordered a nice teddy bear online from a vendor in another member state, and what she got is something completely different than she expected. Now, of course, if you, so when she contacted the vendor and saying, okay, there's a problem, he didn't want to take the responsibility, it resulted in a dispute between the consumer and the vendor. And to solve these kinds of issues today, if you have to take these kinds of disputes to court, it takes a lot of time and it's very, of course, very costly. So the European Commission has proposed a solution to this problem, which is the online dispute resolution platform, the ODR platform. And actually, the solution is actually two-folded. First of all, there are some alternative dispute resolution entities assigned in the member states, which are third parties that help consumers and traders to come to an agreement without them having to go to court. And then secondly, they've built this online platform where consumers and traders can file their complaint, look for the available ADR entities, select one, and get their dispute settled online. Now, of course, to set up such a platform, there were a couple of challenges ODR had to face, and one of them was that they had to find a way or a solution to exchange electronic data between the central ODR platform and these ADR entities in the member states. And this is, of course, where eDelivery comes into play. So looking at the bit of the state or the challenge they faced with, so on the top, on one side, you had the central ADR platform, and on the bottom, you had the different ADR entities in the member state, which were all based, of course, their backend systems on different technologies, using different protocols for information exchange. Also, the ODR platform had its own legacy system and its own technologies. On top of that, there were different approaches in the member states. Some member states wanted a centralized approach, where all the information from the ADR entities would go via one central national gateway or node, and the other member states wanted a more distributed approach. So in order to deal with this diverse landscape, ODR decided to use eDelivery. And what the benefit of eDelivery is that instead of having to set up point-to-point connections between the central ODR platform and all these different types of ADR entities in the member states, each participant in an eDelivery message exchange network has to implement his own Ceph eDelivery access points. They just connect to that. And all these access points, they are conform to the same technical specifications, which there on top of the slide. So the technical specifications are based on the AS4 profile of Oasis. And because they are conformed to the same technical specifications, they can exchange data with any other access point in the network. So, and now the integration then with the backend systems is implemented or is realized as, and of course, the responsibility and the flexibility and the freedom of the member state itself. So, eDelivery actually helped ODR to overcome that challenge of this complex landscape that they had to face in the member states. Next to this, they eDelivery has also some other advantages. For example, if you exchange data over the internet, you want it to be secure. So eDelivery offers some functionality to ensure message integrity and message confidentiality. Then there's also message filtering, which was particularly important for the member states which had a central access point, so that when a message was sent to that national central access point in the member states, they could know to which ADR entity they had to send it. Message correlation, to ensure that all the messages related to a single complaint from a consumer can be grouped. And of course, proof of sending and receiving, error handling, and things like that are only a couple of examples of functions that are offered by eDelivery. Now, to implement eDelivery, there are currently some software available that is compliant to the technical specifications that eDelivery promotes. One of them is, of course, the first one listed is Domibus, which is the sample software provided by the European Commission itself, and which is actually the software that is currently available on FIWARE. But there are other vendors who provide a similar software, which is also compliant to the same technical specifications. And then before I pass the floor to Joanna, quick bit of zoom in into what now this four-corner model is. So, as I mentioned, eDelivery based on a four-corner model using access points to exchange data. So this means that the backend system of the sending party, corner 1, does not directly exchange data with the receiving backend system, corner 4, but it goes to access point. Each party has its own access point. So the backend system of the sender sends his message to his own access point, corner 2. There the information is put in the right format, encrypted, and then it's sent to the access point of the receiver, corner 3, and then there the data again is transformed to make it, to be able to send it to the backend system of the receiving party. So this is actually the four-corner model, but I think Joanna will give a bit more detailed explanation during the demo. So thank you, Joanna.
Okay, so thank you, Brit. I am Ioana, and I am a developer on eDelivery. I will continue the presentation with a demo, and I will start exactly from the four-corner model that Brit already started to talk about. And I will show you how easy it's for two backend systems that were developed independently to exchange messages via the access points. As the backend system, to simulate the backend system, I will use the SOAP UI tool because it is able to send messages to our access point. And as the access point, I will use Domibus. And what Domibus is the sample implementation. It is an open source project of an AS4 access point, and it is maintained and developed by the European Commission. Now, to integrate the backend system with Domibus, it is a work that remains in the work of the, thank you. So the user of the sample implementation is totally responsible to integrate its backend system with Domibus, with the access point. But for this, we facilitate it via a plugin model, where Domibus allows a plugin that will facilitate the integration between the backend system and Domibus. This is something that the user of the sample implementation needs to do, but we also provide some examples, and we have two default plugins. One is a web service plugin, and the other one is a GMS plugin. For this demo, I will use the web service plugin because it is able to accept requests from the SOAP UI, the tool that I will use to simulate the backend systems. The demo will have three parts. The first part is to launch an instance where Domibus is installed. The second part is the configuration of the access point, and the third part is to actually send a message. The launching of the instance, we have two options. I will show you it is very easy to install Domibus either using the FIWARE laboratory or by using the Docker image. So thanks to the FIWARE team, we already have a public image on the FIWARE laboratory, and it is very easily to log into your account on the FIWARE lab to launch the instance, and just like that you have an up and running instance of Domibus. This instance that will be deployed on the FIWARE laboratory and that I will demo right now is already pre-configured to talk to our connectivity test platform. So we have a connectivity test platform, and everyone that is setting up a Domibus or another AS4 access point can use the connectivity test platform to test its setup. So right now I will go to the first step, and that is to launch an instance on the FIWARE lab. So I am going to the FIWARE lab. I will log in using our account, Ceph Building Blocks. And I will go into the cloud. Okay, so here in the cloud you will see, it's probably very busy because there are a lot of presentations now. So FIWARE is very accessed right now. So right here on the instance tab, you can see that we have right now two instances. One is Domibus 3.2, which is a test instance, and one is eDelivery, which is for another component of eDelivery. I am allowed right now my quota on the FIWARE lab is 3 instances, so I will just create another instance. I will just launch another instance to show you how fast and easy it is. I will go to Images, search for our image, and our image is Domibus 3.2, release 5.4. 3.2 is our latest release, and 5.4 is the FIWARE release. I will click on the launch and make sure that it's really Domibus. I will give it the name FIWARE demo. And because we do have enough resources, I will choose a medium one. Right now I need to select a key pair that I already created before, so I am able to SSH on the machine. I won't need this during this demo, but it is required here. And I will select the security group, which is also pre-created and allows access on port 8080 and other ports that I need in Domibus. The network is the network that my instance will be created. I am choosing the first one. It doesn't matter. And right now I am launching the instance. So if you look now, I have the FIWARE demo. The instance is built in the state build, and in a few minutes it will start and it will be active and ready to be used. Because it takes a few minutes to start this image, I will go back and talk a little bit about the configuration. So the configuration of the access point is of all AS4 access points are done via processing modes. What is a processing mode? It is a collection of parameters that determine how the messages, the user messages, are exchanged between two access points. The P mode, the processing mode, specifies which are the partners, where are the URLs. For example, you can see here that we specify the endpoint URL. We also specify the party ID, and to make it very easy to recognize, we use some colors here. So the FIWARE laboratory instance is Domibus Blue, and the test instance, connectivity test platform instance, is Domibus Red. And we specify the URL where this will be available. Okay. Now, in the P mode, you can configure other parameters. You can configure the retry parameters. You may specify how many retries and for how long the access point, the sender access point need to have in case of failure. You can configure if non-repudiation is true or is not or is false. In case it is true, then the receiving access point will have to send a signed receipt to the sending access point to make sure that the message was received and we have the proof of the receiving. You can also configure the retention policy, and that is on the receiving access point, you can specify for how long the receiving access point needs to keep the message that it was received. It can keep it indefinitely, or it can delete it after 6 months, for example. Now, we have 2 access points, and we configure them to talk to each other. Access point C2 knows about access point C2. There is something else. This is not enough. There is something else that we need. What do you think that these 2 access points need? They need trust. It's not enough to send a message from C2 to C3 and to say that, okay, I am C2 and I'm sending you a message. You need to trust me. We handle this trust and the security via digital certificates to make sure that C2 trusts C3 and that C3 trusts C2. The 2 access points need to exchange digital certificates. C2 needs the public certificate of C3, and C3 needs the public certificate of C2. The configuration of these public certificates is done in the configuration, in the security file, and we have to specify three things. First is the alias that C2 and C3 are using. The second one is the password for the key store and the trust store for the public certificate and your own private certificate. And the third one is where these certificates are located, the location on the disk for your certificates. So once you configure the trust between the access points, you configure them to know about each other and to be able to talk with each other, and you make sure there are no firewalls and the network is working, then you are able to send messages from one access point to the other access point. Okay? So now it is time for actually sending a message, and let's go back to our instance on the FIWARE lab. You can see here that the FIWARE demo instance is the same as the others. It is up and running. It is active. And if you look at the eDelivery instance and the FIWARE demo instance, there is a small difference. The second one has a floating IP. This one, 192, is the internal IP. We cannot access the instance using this IP. We have to allocate a floating IP, and it will become available on the internet. So I am going to the security. I have one more floating IP. The quota is 2. And I am associating the IP with the FIWARE demo instance. So before I click the association, I will just cancel it a little bit. I will copy this and go into the browser, and I will access the Domibus administration console. So right now it says connecting and it is not available. Once, you see, it cannot be reached. Once I will allocate this to the newly created machine, it is allocated. I am going back to instances. FIWARE demo has a floating IP, the same as eDelivery. And I am going back to the browser. And I am waiting a little bit. So we might need to wait a little bit longer, because what happens in the background right here on the FIWARE, it is, although we see the machine as active, the instance has started, but in the background MySQL is starting, It is up and running. Once MySQL it is up and running, it will run some scripts to create the tables and the databases for Domibus, and then Tomcat, because we in this demo, we installed Domibus on Tomcat. Tomcat is starting, and Domibus will access the MySQL database and will be up and running. So this might take a little bit longer, probably because there are many demos right now. And there you go, we have it up and running. And this is the administration console. The username is admin, and the password is 123456. This is because everyone can take this instance and can take this image and launch an instance and use it for testing. In production, of course, you will have to change this and to have a secure password. I am logging in, and right now I will show you first the configuration. So if you want to, this instance, I already pre-configured it to access, to be connected to our test platform, because I didn't want to take very long time, to configure it. I pre-configured it, and anyone that uses this instance will have it pre-configured to send messages to our test connectivity platform. Right now, if you want to change this, to change the configuration, to connect to a different access point, you can upload the P mode here, and you can also upload the Trustor, the public digital certificate here. If we go to the message log, right now you can see that there are no messages, because it is a newly created instance. Now I will open SOAP UI. I will open the connectivity test, and I will go to send message. I have a message here that it's already in the format that our web service plugin accepts. It is following the EBMS3 format. And right here I have a message. Okay? And this right now is set to send the message to my local host, but I will copy the IP that we allocated to the instance. I will put it here. And I will send a message. We are waiting for the response here. And the result is the message ID, a unique message ID that the access point is returning to my SOAP UI. In a minute. Oh, because I copied it, I didn't copy everything. 1 second. So I will stop this one, and it was .198. So right now it's the correct IP, and I'm sending a message, and there you go, you have the you have the message ID. Okay, so in response you get the message ID that the access point generated for you. You can specify your own message ID and it will be used, but otherwise the access point gives you a message ID. And now I am going to the message log. And you can see exactly the same message ID, that it is acknowledged. Okay? The same, if I go to the connectivity test platform, I expect that I have this message there and that it is received. This is the connectivity test platform. You see it has a different IP. And if I go here to the message log, I log in, the password is different. And if I look here, I have the message and the message is received. Okay? So now what you can do, you know that corner 1, SOAP UI, sent a message to the access point 1, to the sending access point, corner 2. Corner 2 sent a message to the receiving access point, corner 3. And now there is one last step, and that is corner 4 picks up the message from corner 3. So it is a pull. We go back to SOAP UI. We go to download message, and we use exactly the message ID that we received from our access point. If we click here, and we wait a bit, we get the message following the same EBMS3 format, and in the body we have this. All this is the messaging header with information about the message with metadata, and this last part is the small message that I've sent. It looks like this because, not because it is encrypted, but because it is base64 encoded. And if I go to base64 decode, just one from internet, and I click decode, it says, hello Malaga. So this is the small message that I've sent. Now a little bit before finishing about what happened during the sending. So on C2, on the access point C2, first the message was received from SOAP UI. The first step is to validate the message that it has all the information to build an EBMS3, an AS4 message to send it to the other access point. Access point C2 and access point C3 communicate between each other via AS4 protocol. So we need to make sure that the message we receive has all the information to build a correct and full message and full EBMS3 AS4 message. Then the second step is to compress the payloads. This is configurable via the P mode. This will help us reduce the size. The third step is to sign the message. We sign the message with our private certificate, and the message will go to the other access point, and by this we assure non-repudiation. We know for sure that who signed the message is the person that is really the person that says who he is. Then the fourth step is the encryption. The encryption assures confidentiality. Then we go to the P mode, we get the URL, the endpoint of the receiving access point, and that we configured previously, and we are ready to send a message. The sending depends on if something happens in between, then the sending access point will retry if it is configured to retry. And it will keep retrying for a certain period until it will expire, and it will go to a dead letter message queue, and it will be handled by an operator. Now, on the receiving side, the access point receives the message. It checks for duplicates, because sometimes it may happen that the acknowledgement did not get back to the sending access point, and it will be sent twice. Then it decrypts the message, then it verifies the signature, it decompresses the message because it was compressed before signing and before encryption. It validates the original message that it is okay according to the P mode, to the configuration. And the last step that the receiving access point does is to send a signed receipt to the sending access point. And the message is stored, it is persisted on the receiving access point for the period that it is mentioned in the P mode. So you've seen how easily it is to launch an instance, to send a message, and to get it on corner 4 from the receiving access point. Now a little bit about the specification and the technologies we use. The specification, the eSense AS4 profile, is a profile of the EBMS3 and AS4 standards from OASIS. The technologies that we use, we are using SOAP 1.2 between the two access points. We are using SOAP 1.2 with attachments. The payloads are sent as attachments. We are using Apache CXF. You know that Apache CXF is a mature framework. It is supported by a large community, and it is integrated with Spring, and any bug and any problem that may appear, it is very fast detected and solved. Then we are using also from Apache the WSS4J for security. WSS4J provides the Java implementation for the primary security standards in web services. It provides implementation for the WS security header. This is requested by, this is in the EBMS3 specification. And it also provides implementation for the WS policy. This specification allows us to define, provides us the model and the syntax to define the algorithms that are going to be used for signing and encryption. For signing, we use SHA-256. For encryption, we use GCM. To encrypt the data, we use GCM, and the newer W3C specification says that GCM, it is strongly recommended over any CBC block encryption algorithm. For compression, we use gzip, and we also provide the two default plugins, the web service plugin and the GMS plugin. Domibus is available on, is supported on Tomcat 8, WebLogic 12, Wildfly 9, and it uses as databases MySQL and Oracle. Even if your application server is not there or you are using a different database, with minor changes, you should be able to use your database and your application server as long as it supports Java Servlet 3.0. And in the end, I show here the anatomy of a message. Maybe I should show it right here. It is a bit, so this is the header that you've seen in the beginning, and then all this, starting from here, it is the security header, it is the encrypted key with the MGF mask, it is the encrypted data with the GCM that I already mentioned, that it's the one recommended by W3C, and the signature with SHA-256. So as a takeaway from this demo and this presentation is that if in your application you need to exchange messages, your messages are sensitive, don't do it yourself. You can use an AS4 access point and you can let it handle the exchange for you. Thank you.